Alright, today our learning objective is Notes 12.4, which is volume of prisms and cylinders. And we're going to start today with our vocabulary. And our vocabulary, we're going to look at this picture. So focus in on this picture here. And what you should see is this solid, and the solid, I'm just going to outline the solid so you can see it clearly. The solid is a rectangular prism. But it's not focusing on this rectangular prism. So if you go over here and read the definition, it says the number of cubic units contained in the interior of the solid. So we're counting the number of cubes that are inside this shape. When we do that, that is known as the volume. How many cubes does it hold? Alright, so we have some postulates and theorems that we need to go over. The first one is the volume of a cube postulate. So let's write down the volume of a cube is the cube of the length of its size. Now you probably remember this from 8th grade. You take the length of this side, and that's a little s. And since my s's look like 5s, I'm going to use a cursive letter s to the third power, where s stands for the length of the side of the cube. And it's written here as well. Volume congruence postulate. If two polyhedra, or solids, are congruent, that means that they have the same volume. So then they have the same volumes. Alright, next. Volume addition postulate. If I want to find the volume of this irregular solid, then I have to break it down. So the volume of a solid is the sum of the volumes of all its non-overlapping parts. So this shape right here is going to equal, the volume of that shape equals this shape plus this shape. So that volume equals that volume plus that volume. Alright, next, theorems. Volume of a prism theorem. The volume of a prism is the area of its base times its height. Now, here you will see in the picture that it has a capital B here. B stands for the area of the base. No matter what shape it is, you'll always see a B there. So we're going to say the area of the base, capital B, times the height. And the height is the distance between the two bases. Let's write that down over here. The height is the distance between the two bases. Okay. Now, over here it says that the base of a prism is not always the shape that it's sitting on, the bottom shape. It's not always a rectangle either. Sometimes it is the non-rectangular face. For example, if you take a look up here at the cube, it's sitting on a square, but no matter if you tumped it over on its side or turned it upside down, it would still be sitting on a square. And a square happens to be a rectangle. But if you take this shape right here, notice how this one is sitting on the pentagon, but this one over here is sitting on a rectangle. So over here, just because this is sitting on the rectangle doesn't make the rectangle the base. The base is the non-rectangular shape. If it has a non-rectangular shape, that's the one you use. It's also the one that gives it its name. So this one, we call this a pentagonal prism. So the pentagon is the base. Alright, so here, volume of a cylinder theorem. The volume of a cylinder is the area of its base times its height. Okay, so volume, you should start to see that it's always going to be the area of the base times the height when we're talking about prisms and cylinders. The shape of the base is going to change, but it's always going to be whatever that shape is, it's going to be the area of that shape times its height. Okay, next page. All right, now we're going to practice some, and you're going to do some check for understanding as well. This first one, it says, refer to the prisms at the right, use the formula on the previous page, or use the star formula chart, round answer to the nearest tenth. Okay, make sure that you're always rounding at the very last minute. You don't round. You can write down the rounded answer, but you don't use that answer to calculate your final answer. Okay, so if you don't have a calculator, now is a good time to get one. All right, this shape right here is a rectangular prism. See how that's the name? Rectangular prism? So the rectangle in this case is the base. The base is a rectangle. And since all of this shape is made of all rectangles, it doesn't matter which rectangle you use. I tend to always use the one on the bottom in this case. So I'm going to use this one here. All right, so the dimensions of the base are going to be 10 centimeters by 12 centimeters. So that means that the area of the base, capital B, area of the base, is going to be length times width, or base times height. So that's going to be 10 times 12. 10 centimeters times 12 centimeters happens to be, you can do that with mental math, 120 centimeters squared. Now remember, we've used this one and this one, the 10 and the 12. So the distance between the two bases is going to be the 7. So the height of the prism is 7 centimeters. To find the volume, you just multiply those two together. 120 times 7, that's going to be 840. And then remember, volume is centimeters cubed. Now take a look at what you have here. Here you have centimeters squared, and here you just have plain centimeters, so that's like centimeters to the first power. 2 plus 1 is 3. So that's how you can remember it. All right, the next one says a regular triangular prism. So this time the base is a triangle. And not only is it a triangle, but it's a regular triangle. If you look, that's 14, 14, and 14. Okay, so I'm going to draw that right here. Here's the base. Notice how it's not sitting on the base. All right, so this is, I'm just moving this over here. 14, 14, and 14. So this side is 14, this side is 14, and this side, if we cut it down so we can find the height of the triangle, not the height of the prism, the height of the triangle, that means that's going to be 7 and that's going to be 7. So to get the height of the triangle, I have to use some additional information. I have to use Pythagorean theorem. A squared plus b squared equals c squared. So that's going to be 7 squared plus the height squared equals the hypotenuse squared. That's going to be 49 plus the height squared equals 196. And now, plugging that into my calculator, I'm going to subtract 49 from both sides. I get the height squared equals 147. The height is going to be the square root of 147, and that doesn't reduce. That's considered to be the exact answer of the height of the triangle. So when I plug it in, that's what I want to plug in. All right, so now let's go here. Find the area of the base. Capital B is going to be a triangle So it's base times height divided by 2. The base of the triangle is 14. The height of the triangle, this is what you want to plug in, the square root of 147, and divide that by 2. So now, if you look, it's easy to divide these two. That is 7 rad 147. That is considered to be the exact answer for the area of the base. So I'm going to put this out here, 7 rad 147. Now remember, our instruction said round to the nearest tenth. So that's when you're going to plug it into your calculator. 7 second rad 147. Always get in the habit of closing your parentheses. Enter. Make sure you're rounding correctly. I notice that some of you are still having problems with rounding. We're rounding to the nearest tenth, so we're rounding to the 8. So that means we look one more over to the hundredths place. That tells me to round up, so that becomes a 9. That's 84.9. And always put your label. This is meters, and this is area, so it's meters squared. Find the height of the prism. That's the distance between the two triangles. So that's going to be 10 meters. And, okay, so now, if you look, what I've done is I've written down the rounded answer. Do not use your rounded answer to find the volume. This is already loaded in my calculator. To find the volume, I just multiply these two together. So you take this answer and you multiply by 10. That gives you 848.7, and of course that's meters cubed. Meters squared plus one more makes 3. All right, now if the instructions asked you for your exact answer on the volume, you could still find that because you would multiply these two together. Because this is 7 times the square root of 147 meters squared. That's your exact answer. So multiply those together. This would be 70 rad 147 meters cubed. Okay, so that's exact. And that's rounded. Okay, on this next one, you're going to do this one by yourself. I just want to point out that this is a triangular prism. That means that the base is a triangle. And so you're going to do this same basic thing up here, except for you already know the height of the triangle. Remember that when you have a right triangle, the two legs are the base and the height. So this is 5 and this is 12. So you can find the area of the base without having to do the Pythagorean theorem because you don't need this side over here. The distance between the two triangles is 9. So make sure you plug in the correct information. And those of you that are still struggling with formulas, make sure that you're using the right one. Go to your formula chart. It's base times height divided by 2 for the triangle. Alright, again, this one right here, you're going to do this one by yourself. Now, don't be afraid of the 30, 60, 90 triangle. Let's draw that over here. Okay, so this top one is 30, this is 60, and that's 90. Across from the 30 down here, that short side, that's an 8. They tell you, they didn't need to, but they do. They tell you that this is 16. But we could have found that just with this, because we know that the hypotenuse is double, and we know that the long leg is going to be 8 rad 3. Put all my labels, that's going to be centimeters, centimeters, centimeters. And again, this is a right triangle, so to find the area of this, it's base times height divided by 2. Okay, next one. This one here, you're going to do this one by yourself. This is a trapezoidal prism. So that means that the base is a trapezoid. Let's write down area of a trapezoid. Remember, folks, you can find that on your star chart. Remember, it's base 1 plus base 2 times the height divided by 2. So let's take a look at this. Base 1 is, remember, the bases are going to be these parallel sides. These are called the legs of the trapezoid. And this is the height because you see the perpendicular mark. So this base right here, base 1, that's going to be 12 inches. Base 2, that's going to be 8 inches. The height, that's going to be 6 inches. And then the distance between the two bases, which is the height of the prism, we know that that's 10 inches. So I'm going to write that over here, 10 inches. Did we even need that 7 there? We didn't even need this 9 over here. They put that as extra information to confuse you. But don't fall for it. Just go ahead and list all the information that you know so you can plug it in. All right, make sure you have these 3 when you come to class completely done so you can get full credit for your notes. All right, next page. All right, on this one, again, that's your check for understanding. You're going to do this one. That's a cube. The area of the base, well, it's a square, so you should be able to find that all on your own. You should be able to find this all by yourself. Make sure you bring this one in. Don't forget your labels. Let's go ahead and focus on this one. We're going to do this one together. All right, hexagonal prism. So that means that the base is a hexagon. And when the base is a hexagon, remember, that's that the area of a hexagon is 1/2 the apothem times the perimeter. Let's look over here and see what I have. I have the side of the regular hexagon is 6. That means all of these are 6. So I can easily find the perimeter of the base. The perimeter is going to be 6, the length of, remember it's perimeter equals the number of sides times the length of the side. The number of sides is 6 because it's a hexagon, and the length of the side is 6. So the perimeter is 36 yards. Now, to find the area, I've already got the P, I need to find the A. So remember, we have to draw a triangle. It's a right triangle. And remember, this is the, when we do that, we're drawing it like this. So we cut this in half. So that's a 3, 3 yards. And then we have to find this angle up here. Remember, to find this angle, that's going to be 360 divided by 2n. The number of sides happens to be 6, so that's 360 divided by 12. Well, 360 divided by 12, that's 30. So this happens to be a 30, 60, 90 triangle. Okay, well, I don't need the radius, because they didn't ask me for the radius over here, and I don't need it for this. All I need is the apothem, which is this guy right here, the apothem. Well, that means that that's going to be 3 rad 3 yards. So the apothem is 3 rad 3 yards. Okay, well now I have all the information I need to plug it into here. That's going to be 1/2 times 3 rad 3 times 36. So we multiply 3 times 36. I get 108. So that's going to be 1/2 of 108 rad 3. Cut that in half. That's going to be 54 rad 3. Now remember, this is my exact answer. So that's going to be 54 rad 3 yards squared. If they want, the instructions, remember, were to round to the nearest tenth. So I'm going to take this, I'm going to multiply it by rad 3 and round to the nearest tenth. That's 93.5 yards squared. Don't forget your labels because you'll lose 2 points for not putting your labels. Find the height of the prism. That's the distance between the 2 hexagons, so that's 12 yards. Okay, now, you do not multiply 93.5 times 12. You have the area already loaded into your calculator, so do not use the rounded answer, you use the real answer. So times 12, there's your volume. 1122, round to the nearest tenth, 0.4 yards cubed. 2 plus 1 make 3. Now, if you wanted an exact answer on this one, remember, all you have to do is multiply the 12 times the 54. 12 times 54, that's going to be 648 rad 3 yards cubed. This is the exact, and this would be the rounded answer, your decimal answer. Okay. The next one, next section, we're doing cylinders. Okay, changes the shape. The shapes on cylinders, the bases are all circles. So the base is a circle, so the area of a circle is pi r squared. Alright, so this one, I know that my radius equals 4 inches. So that means that the area of the base is going to be r squared, which is 16 times pi. Remember, you always put the number first, 16 pi. That is my exact answer. 16 pi inches squared. They want me to round the answers to the 10th, so I'm going to plug that in. 16 pi. So that's going to be approximately 50.3 inches squared. The distance between the 2 circles is the height of the, oops, that should say cylinder, and that should say cylinder. All of these are wrong. These are all, that's a typo, so go ahead and fix it. All of these should say cylinder. The height of the cylinder is 12 inches, and then if you want the exact answer, you multiply the 12 and the 16. So 12 times 16 is 192, so 192 pi inches cubed is my volume. Or if you want your decimal answer, you're going to take that and multiply it times pi, and you get 603.2 inches cubed. Alright, folks, you're going to do number 2 and number 3 by yourself. And bring it in. Make sure you get this one, and this one done before you come to class so you can get full credit for your notes. Alright, last page. On this page, notice how they don't give you any pictures. You're going to have problems like this. One strategy is to draw pictures if you want, but you don't have to. Read each situation carefully. Draw the figure and solve. That's a strategy. Write the formula to solve and show your work. That's a strategy. Use the pi key and round your answers to the nearest tenth place. Okay, so on this first one, it says the inside dimensions of a rectangular box are 8 by 5 by 10. So I'm going to draw this rectangular prism that's 8 by 5 by 10. And it's going to go up into my word problem here. Alright, there's my shape. 8 inches by 5 inches by 10 inches. Alright, so if I'm asked to find the volume of the box, which I am, I'm going to do the area of the base, times the height. Well, the base happens to be 8 times 5, which is 40. So that's going to be 40 times the height, which is 10. So this is 400 inches cubed. Then it says, how many cubes with the dimension 2 inches by 2 inches by 2 inches can be packed perfectly into the box? So now we have another shape. We have this cube, which is 2 inches by 2 inches by 2 inches. So the volume of the cube is going to be 2 times 2, which is 4. The area of the base times height, so that's going to be 4 times 2, which is 8 inches cubed. Now, they're asking a question that says, how many of these will fit inside here? Well, that's just a division problem. So to find out how many cubes will fit in here, you take your 400 inches cubed and you divide it by 8 inches cubed. So on my calculator, 400 divided by 8, that's 50. So that means 50, the answer is 50 cubes. Now make sure you label 50 cubes. It's asking you how many cubes will fit, so make sure cubes is your label. Alright, this one you're going to do by yourself. Let's go through these steps up here so you make sure that you follow all the steps. Step 1 is to find the volume. Step 2 is to, you don't have to find the volume of a second shape, because what they do is they're saying that it fills with water at this rate. So what you do is you divide the volume by the rate. So whatever you get as your volume, you're going to divide it by that 15.1. Step 3, label your answer. Okay, so make sure you bring this one completely done when you come to class. The next one, the volume of a rectangular prism is this. They give me the volume. It says that the length and the width and the height are all tripled. Tripled means times 3. Find the volume of the new resulting prism. So you have two prisms. You have a small one, and then you have one that's growing because it's being tripled. So I have a small and a large prism. Okay. Now you should start to recognize this already. Right, lengths. This is the ratio of the lengths. This is the ratio of the areas. And this is the ratio of the volumes. Alright, so this is the only new column that we're adding. We've already been dealing with columns that look like this. Okay, so if you read this here, it says that the height, width, and the length, we don't know what they are, but we know that they've been tripled. So let's say that in this small triangle, if I have 1 unit, for it, 1 unit in the small one will equal 3 units in the large one. So that's the ratio of the lengths. Now remember what we do to that to find the ratio of the areas. To find the ratio of the areas, we square them. 1 times 1 is 1. 3 times 3 is 9. Now remember, this is measured in units. This is measured in units squared, and this is measured in units cubed. Alright, so see how we square these? Well, to get this one, we cube them, or to the third power. So 1 times 1 times 1, well, that's 1. 3 times 3 times 3 is 27. But I'm going to show you how to do that on the calculator, just in case you don't know. There's 2 ways. You're going to put in 3, hit the math key, and if you scroll down, you'll see this little 3 here. So you're going to scroll down, enter, and it says 3 to the third power. Enter, you get 27. Another way to do it is 3, use the caret key, that says 3 raised to the third power, which is 27. Okay, so this is 27. Alright, so now this is the ratio of the volume, so that's the one that you use in order to find the new volume. Okay, so the small one, the volume of the small one is 24. We want to find the volume of the large one, so that's what we're looking for. You've got to use this ratio here, 1 over 27, and then you cross multiply. So 24 times 27, that means that that's going to be 648. So the volume of the new resulting prism is going to be 648, make sure you use the same units, meters cubed. Alright. The next one, we have a tank. It's kind of an aquarium, and it's being filled with water, so it's kind of like a fish tank. It says the diameter of the cylindrical aquarium is 20 inches, so it's like a cylinder, and we know that the diameter all the way across is 20 inches. And then all the way to the top is 32. So from here to here is 32 inches. But if you fill it all the way to the top, the water is going to spill over. So if you read the question, it will tell you that the water only goes up 31 inches. So they cut the water off here. And in the bottom they put rocks. So there's all these rocks down here. What they want you to find is the volume of the water. So the rocks, they displace the water. So you want to find the distance between here and here. You want to find the volume of this. Well, to do that, you're going to find that the volume of the water will equal the volume of the cylinder, but not at the top of the height, only to the top where the water goes, the water line limit. So where the height had been changed to 31 inches. Okay? Then you're going to subtract the volume of the rocks. And they give you that information. Okay, so you're going to finish this one by finding the volume of the cylinder using this height. And that, make sure you find the radius. So find the volume of the cylinder and subtract off the volume of the rocks. The next one down here you're going to do also by yourself. It's a cylinder, but it doesn't matter. You're going to have a small one and a large one. It says the volume of the cylinder is this. If the radius and the height are doubled, remember doubled means times 2, find the volume of the resulting cylinder. So you're going to set it up just like this up here. You're going to put small, and you're going to put large. These are the lengths. These are the areas. These are the volumes. Okay, so remember that times 2, remember what did we do to it? You're going to set it up just like we did up here and solve that. Make sure you bring this one in with you when you come to class. Alright folks, that's it for our lesson today on Notes 12-4. Make sure you go back and do all of your check for understanding so you can get 100% on your notes.